This is Unevenly Distributed, a podcast from Nexavize.com, where we talk to experts to find out what's next in digital technology and where it's real today.
This is Unevenly Distributed, a future tech podcast, and I'm Jeff Villemek. Today I'm joined by an expert in artificial intelligence, among other things, and the head of innovation at Google Cloud with a focus on data and transformation, Rachel Levy. Rachel, welcome.
Hey, Jeff. Thank you. And thanks for having me.
Thanks for being here. This continues some discussions on AI that I was really excited to get into. Talked a little bit in a recent episode about green computing and why building AI needs to take that into consideration. But I'm hoping today with you, we'll be able to get deeper into what is AI, what has it been doing, what has it been doing the last couple of years. But in order to think about that, one of the things that's been on my mind for a number of years now around AI is this idea of, is AI ready for us to make use of it? Is it ready for the plateau of productivity? If we think about the Gartner hype curve. One of the ways to think about that also is the AI winters that we've experienced in the past. In its modern form, AI was sort of devised in the 1960s, and a lot of research went into it and funding went into it. And then by 1975, it sort of had fallen off the curve in both investment and people paying attention to it and developing it. It came back again a little bit in the early 90s. And then by 1995, it was another sort of like dip, an AI winter. In both of those situations, in my mind, it didn't really get out of that trough of disillusionment in the Gartner model. Came back again in the mid-teens, 20-teens, and a confluence of hardware and a confluence of new approaches to models put things together where we could start some really broad experimentation and development of AI, machine learning, and a whole bunch of related kind of algorithmic work. And watching that at the time, I had the question, so back 2016, this is the question that I asked. I think it's been answered. I saw that we had $36 billion of investment in 2020, and then that went up to $77 billion of investment in 2021. And I don't see it slowing down anytime soon. In fact, the projections are doubling again by 2025. So I think we're on that plateau of productivity. There's both the investment and there's how we're using it. Do you agree? And what is your assessment of, are we there? Is it here to stay?
Yeah, I think of it in a couple ways. One, I think of applied AI and AI research completely differently. So I think of people who do AI research are people who are inventing an oven. And then applied AI are the cooks that are like, okay, how do we use this? Like, I don't really know how to cook, but if I did know how to cook, I still wouldn't know how an oven was invented. And I don't need to know that. So I think people are spending more time making the ovens easier to use so that more and more there can be that democratization of AI, that you don't need a PhD in order to build models, but it's really about providing, thinking about your deep domain knowledge in your field and being able to not let technology be the barrier to you being able to benefit from some of the AI that's being developed.
What a great analogy. And I really like that idea. And I think this is important for people to think about and understand. And I'd love to even talk about it a little bit more. The building of the ovens. So another thing that I felt like I saw in 2015, 16, 17 is everyone was building their own oven. Every big company was hiring data scientists. Everybody in our basements was putting getting a Jupyter notebook and putting some models together, and everybody was building ovens. I think we're at the point, and I think for really good reasons, where a bunch of really good ovens are getting built out there by some of the biggest players like Google, and our ability to grab those and do interesting things with them, do some baking, or grabbing baked products, and we're really stretching the analogy here, but grabbing baked products and shoving them into our tools and applications and business solutions that we're building, I think that's where we're getting to now. So although there isn't as much flurry around new ovens that are being built, hey, I built a model to detect XYZ. There's a couple standouts, DALL-E and GPT-3, and but individuals spitting out new models and writing papers or writing articles on them, a little bit less of that. You could look at that out of the corner of your eye and worry that things were slowing down, but I think it's the opposite because the baked products and the ovens are being used an order of magnitude than anyone was ever building those models in the past couple of years. Is that make sense?
Yeah, I completely agree with that. I think too that people, yeah, are just using the ovens and making their own baked goods again to keep the analogy going. And I'm have a master's in statistics, so I can say this because I was a data scientist consultant. Like data scientists can be divas because they're in high demand. They know that everybody wants one. You say, oh, all these big companies hired them. It wasn't just big companies. Everybody hired data scientists, and it still are. But there's a way of thinking about artificial intelligence where it's less about like the specific model and more about the application of that model to your business. So what you really need is people who understand data and then your own business or your own domain rather than the inner workings of an algorithm.
That makes sense to me too. It's a shift between data science to almost data engineers. So the pure science of building the most perfect model versus the engineer, which can apply the science to real world problems, that's where we're seeing a lot of day-to-day use of AI. And I would hope that a lot of any company is getting to that point where they can either be focused on the engineers applying those models to their solutions, or even, and how much I wonder of the split of this, even just ignoring, just forgetting about AI instead, as a company that doesn't need to, and instead just benefiting from AI that is now infiltrating every kind of business application that's being created, and every business application that we use.
Absolutely. I see that. And I think that really ends up both empowering people, but also questioning what is the value of a model and perfecting it. Like if you're measuring, R squared or any like MASE or any of these like metrics around prediction and accuracy and precision, data scientists generally can get and tweak and tune models to be closer to perfect. But if we're talking about a very small difference, is that necessary for a business? And I think it really depends on the application of the model. Sometimes like a 1% uplift is worth it. Like if you're a large financial institution, a 1% improvement in your fraud detection could be hundreds of millions or billions of dollars. So you want to improve that. But if you're a retailer that is using AI to do recommendations or also purchased with, et cetera, is that 1% really going to actually make a difference? And where should you be focusing your engineering effort? Is it that 1% uplift or continuing to evolve places or other places that AI can exist in your business?
Especially since, and I learned this talking about green software and this development of the AI models, that final 1% can sometimes be orders of magnitude more than the previous 99% in terms of effort and cost and data science and the compute that it takes to make that happen. So is the ROI there? That's certainly a key question. And then because we've got the great ovens and the baked goods integrated into all of the tools that we're using every day, they're getting baked into the ERP solutions. They're getting baked into our baseline data reporting tool sets that we use to even do data projection and do analysis on our supply chain. They're getting baked into our CRM tools to help us develop a marketing campaign and target customers. If they're all baked into that, then great. I don't need to hire a room full of data scientists to spend 6 months or a year in order to figure out how to target customers because they're baked in. So are you seeing that baking in of AI in all whole? I feel like, and I know it's happening in a lot of places, but I feel like this invisible proliferation of AI into all business applications is sort of where we're getting to now. Are you seeing that as well, and do you expect that to continue?
I am, and I do, though I see the performance at times being really good. But there's also, I've seen times where performance is not where it should be. The models aren't quite up to snuff. Or frankly, people not trusting the output of the model. I think that is always going to be a barrier that humans have the ability to think dynamically, where a machine learning model is often programmed with like, here are all the inputs, here are all the outputs, like, and here's my prediction, right? But things change. Like, we look at 2020 and there was a sudden turn that like all of the predictions coming out of models were almost irrelevant because the data itself, the underlying data and the events, like reality changed so much that you could no longer apply the models from the data that was trained pre-2020 in like the years after that.
I think it bears repeating that statement there, and a lot of people sort of need to understand that in order to create an AI model, the way most AI models work today, you give it a data set and you train the model on that data set, and then it's able to, once it's presented with a new situation, match it to what it understood about that data set. If reality has changed, which it has, spending patterns have changed, supply chain distribution, supply chain networks have changed, how products are sourced has changed dramatically the last 2 years, all of those models potentially need to be tweaked or redone in order to be more accurate to where we are today. A lot of them still probably in general are still useful to some degree, but some are probably not useful at all. In that way, in what cases would you recommend, say, a medium-sized business that makes glass jars for a manufacturing facility that makes glass jars? In what cases would you recommend that they still want to have some data science on staff and thinking about these kinds of things versus just waiting for the ERP companies to catch up and rebuild their models and redistribute them?
Yeah, so I think it depends on the use case because, right, there are CRMs, there are sales forecasting and predictions, but there are actually a lot of other ways to think about using AI in that very glass factory. Something I have seen and I'm thinking about is around using image detection to identify impurities in glass as it's being cooked based on the temperature that the glass is throwing off, because an impurity in the glass causes things to shatter, break. So I've seen like essentially heat cameras identify anomalies in glass factories so that your every glass bottle you have is more uniform than the one that you used to make. That so it's like, yeah, you don't necessarily need to be doing the CRM models. I do believe that the large companies and the models are trained enough, but there are so many other use cases that are domain specific that are true regardless of what's been happening around the world.
That makes sense. So we're not taking the data scientists off of that diva pedestal just yet.
Not yet.
They will still get to remain there, which is important for anyone that's thinking about getting into data science to realize it hasn't been solved, and I think it's only going to continue to grow as a field as well.
Absolutely, but rather than thinking about it strictly in the math sense, somebody had to realize that how can we translate the manufacturing of glass to math? And only like a data scientist has that sort of, not only, but generally a data scientist is the person to do that, to say, this is how I would think about it, because somebody had to decide that we're going to use artificial intelligence, computer vision to perfect glass bottles, not just in what do they look like, but what is the actual composition of the bottle.
Yeah.
That was a data scientist.
That makes sense to me. And this is the way I've always sort of thought of data science, which is it's less about the answers. We can get a bunch of numbers, we can get a bunch of sensor data, we can even put machine learning models on it to look for particular trends. That's a bunch of answers. The answers are easy. It's finding the right question to ask of the data, which is where you need somebody smart. You need a data scientist to go off and do that.
I completely agree with that. Yeah. Like, so I always sort of say, like, data analysts are amazing at answering questions. Data scientists are amazing at asking questions. And the skill sets can be transferable, especially if you can both answer and ask the questions.
Yeah. That gets me to if we were talking about data scientists and what their job will look like. One of the key concerns about this data science and artificial intelligence and looking for impurities in glass bottles, that could be somebody's job today, a materials engineer that's on the line, sort of looking for this kind of thing. One of the fears of the development of artificial intelligence machine learning models is that it's going to take away jobs. It's going to take away and take all of the things that maybe that I do for my career and make that disappear. I don't believe that's the case. What are your sort of thoughts on where AI really makes sense and what it's going to do?
Absolutely. So I sort of approach machine learning, data science, whatever you want to call it. I encourage organizations to approach it with what I call the centaur model, right? Where centaurs are really, really like they have the head of the human, right, and the body of the horse. So use the horsepower to churn out models, to process data, but use the human ingenuity, the human touch, the creativity to think about how to apply that horsepower. I worked on a deployment of a chatbot with a large financial institution, and they were automating part of their call center. And for their website and their application, you could just chat rather than wait to speak to a representative. When the chatbot detected the intent, like I'm calling to get my balance or know when my credit card payment is due, that is super automatable. The top 10 intents represented close to like 40% of the reasons people call. But if somebody is calling to say, I want to apply for a loan or a mortgage, that should be handled with a white glove, like well-trained person, not a machine learning model. It is too valuable to entrust that to machine learning. So it's really saying, taking that rote, automatable tasks that are actually probably super boring for humans, like offload that to machines and really allow humans to flourish where they're going to be most successful.
I agree. And when I've worked with companies talking about potential uses for artificial intelligence, it's the human plus the machine doing more, being more accurate, being more effective. We've got AI models that can assist in the legal profession. They can help with discovery, for example. That doesn't mean that we're going to hire less lawyers. It means that the lawyers are going to be able to be looking at the best, the right things, the best things. Same thing in the medical profession. And now we've got radiologists that can be assisted by looking at having AI models that help look for tumors. That doesn't mean that we need less radiologists. It means that the radiologists can be looking at the right things because they have a partner that's helping them narrow down this growing set of data in their world as well. Is these growing sets of data narrow it down to look at only the places where they should be spending their human time. That makes a ton of sense. There probably are fields where some jobs may end up going away, but even those, it's a little bit further off. If we get fully self-driving cars, yes, that will change some careers and some jobs in some places. But the vast majority of where machine learning and artificial intelligence is going to affect these major careers and major job markets is being a partner to and making them more efficient, making them work better, which is good for us all.
I agree. I do think it would be short-sighted to think that it won't affect the job market. I don't personally know how, but it will. Like you said, there will be jobs, and like I even think about some of the machine learning that's being developed right now is ML that can generate computer code. It's like, oh my gosh, these machine learning engineers are, automating themselves out of a job. No one is safe. But it doesn't happen like a light switch. I don't think it's like, and all of a sudden we don't need these people. I think it's a way of like realizing that there's going to be change to a ton of industries and hoping to find a way to adapt and grow with that change rather than resist it. I think the resistance is is where like resistance of fear and fear of change is going to be causing, like inadvertently causes that thing that most people fear the very most. So
Yep. I've looked into some of those coding assist tools and some of that sort of like a confluence of GPT-3 and being able to look at everything that's in GitHub and all code that's sort of been written and submitted in the last decade and write code at the behest of the coder. So you need the coder for one, so it's not just writing code, and it's writing snippets of code. So again, getting back to our cooking baking analogy, it's almost like a prep chef on the side chopping some vegetables for you that then you can grab and put into your dish. You
Yes.
still need to be cooking and making the dish. You need to be the chef, but now you have an AI prep chef that helps slot some of those code pieces in that you can describe what you kind of need, but you need to know what you need, and then it will spit out the chunk of code or a class or a little snippet that says, okay, well, here's something that figures out the date, like you're looking for. It calculates leap year. Okay, I could have done this. It's better that it goes and grabs it, or I could have gone to Stack Overflow and just copied and pasted, like we all do as coders. It's great to have those kinds of tools, and then again, you're getting into solving the problem and less of the rote plumbing underneath. And we haven't yet gotten to AIs that are really good at creatively inventing new ways to solve business problems. There will be some of that, and although there's still direction that happens on top of it. Maybe we'll get to that in a second with like DALL-E and the creation. But before we get off of it, our glass factory, for example, I wanted to ask, one of the things I saw with that situation, like the glass factory, is I've seen a lot of experimentation. I've seen them hire some data scientists, get some IoT sensors, point some cameras at some stuff, and they experiment, and they even find good results. Hey, we are seeing these defects, and it looks like this is interesting. And then they don't implement it. They don't follow through. They don't roll it out. Why? Why not? Why? What are the barriers to getting that to happen?
I think that's where a lot of machine learning needs to be going, is actually the deployment of models. And there are some very real barriers to entry in this. I think about, I was working with a fast food or quick service restaurant that said, we want to analyze our drive-through lines to optimize them. And so for the proof of concept, we had people sit outside these restaurants with phones, like iPhones or Androids, and just like take video. And we trained the video to be able to count the cars, do all these things. But at the end of it, there's like this really real part. What if the internet connection is slow and it can't send the feed back to wherever the model is hosted? How do you charge these cameras? Like, there is this, how do you literally get the cameras up there? You would have to have somebody actually climb up. You need like construction people almost to actually implement some of this. So there is this challenge of how do we go from this iterative testing, wow, I created a model, in some ways that can be the easy part, to how do I productionalize this and how do I operationalize this and make this actually part of the business? And that's where I'm seeing a huge opportunity in artificial intelligence to think about how to take the toys out of the sandbox and put them into reality.
Got it. I can definitely see that. And this reminds me of some of even going back to the 90s, I did work with McDonald's Corporation when they were trying to figure out putting internet into their restaurants. Are we going to put some Wi-Fi into our restaurants? And us as, smart technology people, we could design, the uses, and here's what it would look like. And, this is the reality of, as you said, now we've got all these restaurants and we're going to be dumping routers into the back room, and we're going to need to be running, partnering probably with an ISP, and we're going to need to be running cables and wires, and then now we're going to need a fleet of trucks driving around and fixing these things when they break. It's all of that infrastructure work, especially when you try to do it at scale, is enormous and immense and very complicated. So even if we could figure it out and schedule out all the pieces and make the cost of putting all of those trucks on the road to install these things and fix them and maintain them, and then get that extra 1% that we're looking at and put this into the ROI model and still make it make sense, it's still a years long planning process when you're doing it at scale as well.
Absolutely. And yeah, I think the other thing I see there too is that it's a huge cost, and then the expectation of people once it starts. So I believe that when people have a great experience with something, it becomes the benchmark of what an experience should be. And I always use the example of when I first got Wi-Fi on an airplane, it was like pretty garbage Wi-Fi. But I still used it because I was so amazed by the fact that I'm over the Atlantic Ocean and can be checking email, which probably goes to a different problem around tech addiction, but we can get back to that, right? But once I got accepted that Wi-Fi can be on airplanes, my expectation is now when it's on airplanes, it has to be amazing. It has to work. I have to be able to stream things if I want to. And so when you start putting these pieces in restaurants or in experiences, the expectation now is that it works and it works well. So I think businesses have to be cognizant of the fact that if you start offering Wi-Fi in that example, the expectation is that there's going to be Wi-Fi, and that it is no longer a value add, as it is an expectation. And yeah, I think that, so you can't be cavalier about, oh, well, we'll just have less of a fleet that's servicing these routers when they break. It's like, no, people will expect this. And I can say I am somebody who expected it. As somebody, I studied writing in France, and when I needed good Wi-Fi, I actually went to the McDonald's because I knew it was reliable. So thank you for whoever put the Wi-Fi there. That was you, Jeff.
Well, it wasn't me, because it didn't really happen until like 5 years after, because of that project. Exactly. Unfortunately. Yeah, that idea that if we're going to move forward with it, we need to solve these, and we need to get it into a state where it can be deployed and maintained, and it's going to work at some performance level, some service level that makes sense. That's when it's going to be production ready. I think there are a couple things potentially coming down the road, and I don't know if you have any thoughts on these, which may help and again may continue to drive the adoption of AI in new and interesting places. And those are 5G, advances in IoT and miniaturization of devices, the sensors, being able to run them off of solar and battery, and you put a few of those things together. And then in the case of 5G, and this was actually the first episode of this podcast, 5G being able to take some of those AI models and run them on the 5G mech, run them on the edge, and deploy them then to those locations and not have to have a box or a hardware or a GPU running in the McDonald's restaurant or whatever. I'm hoping that those will drive those advances once they start to again get to their own service level where we can count on them to be doing this, allow us to further some of those experiments and maybe get more of them deployed. What do you think of that? And are there any other things you see coming down the road that it's going to make it easier to get these models out there and be using them this way?
I definitely agree with the fact that models will be living on the edge, maybe trained on the cloud, but then pushed out and deployed to edge hardware. Though the thing that I think will always be of utmost concern is anytime the internet can talk to a board, whether it's just like a Coral board or any sort of piece of hardware, you've increased the surface plane or the attack plane of vulnerability that I used to like. I don't understand why people put their appliances online type thing. I'm like, oh my gosh, what are you doing? You're clogging up your network. And what are you trying to get out of this? Oh, I can see if my oven's preheated. I'm like, why can't you just stand up and look? But like that, the vulnerability that opens up in your network, yes, they are safe, but people are determined to get on networks and steal information. So I think that is actually going to be a huge blocker. People always say, oh, like the CISO of an organization, this slows everything down, but their job is like to protect the organization. So even as these technologies proliferate, I think there's going to be a lag in understanding how to properly secure them.
Okay. That makes sense. And I will feel chagrined because I have my tea kettle on the internet right now.
Why? I don't understand. I don't understand.
Well, I can yell at it. My favorite AI is my partner. The piece of my centaur is my echo, because I can talk to it and I can tell it to do lots of things. I can ask it lots of questions and I can tell it to do things. One thing I can tell it to do is while I'm upstairs, I can tell it to go start heating up the water, which I think is kind of fun. The attack surface of my tea kettle and the amount of data that it has on me is very, very small. So I'm not as concerned about that.
Yes.
Other situations, yes, I agree. And we should actually at least be cognizant of it.
I think it's a
at
choice.
least be thinking about it.
Right? It's a choice. I always think about the value exchange. Like, it is a very small risk that somebody understands how to hack tea kettles and then can root around on your network and actually get something valuable. The chances of that are super small. And if the value you get from the being able to yell at the echo to turn on the tea kettle, that's very legitimate though. Like, that is totally, like, the risk reward is there for you. And I think that's totally acceptable. Now, the place that it becomes really important and that I think a lot of organizations are rightfully sensitive about is them making that decision for their customers and how much risk they're willing to take on, because it's not just for them, it's for everybody who ends up interacting with them. And I think that's why there is so much sensitivity about it, as I believe there should be.
That's huge. Customer data in particular, I mean, from a regulatory and obligation perspective, is protecting that is, we are legally obligated to protect it, not in addition to us wanting to protect it as businesses. So that makes a ton of sense. Another interesting twist, and I'm interested in your perspective on this, that I even have less ideas around, is one of the promises of AI machine learning was self-improvement. It's going to learn over time, and the models will improve over time. And the vast majority of what I've seen of artificial intelligence machine learning, especially as these models get created, is a model gets created, it gets dumped out there, and that's it. Two things there. One is people not building the process to have the data scientists iterate on the model and continue to improve it. That would be one way for it to happen. And two is models that learn and improve themselves. While that's possible, it's very complex, and it seems like a very small number of models even get close to that. What's your perspective on that, and what are the barriers to that situation?
Yes. So when people do that properly, and I've seen it done, it's often like treating the model like it is as a piece of software and having a CI/CD pipeline around it and really working with it as you would develop and, deploy new versions of software. And test it before pushing it out and automate all that testing. With that, however, comes a whole different skill set than a data scientist might have. That's actually closer to a software engineer skill set. So having like a machine learning operations person or team is necessary. If you're going to be putting models out there, you have to maintain them. I think, in many ways, maintenance is the art of protecting progress. And in doing so, you have to you have to maintain and sustain what you've built and make it better. But that is a process, and that is a set of skills that is very specific. It is not a casual set of skills. And I think that's finding, like, air quotes, a full stack data scientist is actually where that comes in, or it's having teams that know how to operationalize models that data scientists are building.
That's an interesting term. I love that term, full stack data scientist. I work with a lot of studio people and a full stack developer, a full stack web developer, a full stack designer in a studio. I get what that is. I love this idea of a full stack data scientist that can take everything from, and maybe include the business domain knowledge, determining the right questions to ask, building the model. I mean, those are unicorns, though. I mean,
Yeah, I was just going to say, oh man, if you ever find that person, the ultimate diva data scientist would be that person.
all the money. They would get all of the money.
as they should. But
As they should.
As they should, if they can do that. But really having a set of people that are committed to saying, like, something is changing. I think it's really obvious too when things like COVID happen and there's like a stark light switch moment where things are no longer the same. But the harder thing is the drift, right? Where models are like sort of like a boiling frog, that whatever that expression is, like it just gets, it's off a little bit more, a little bit more, a little bit more each day, week, month, that eventually it's sort of rendered useless because you haven't put in the time and energy to retrain and maintain its relevance. And so I that's why I keep going back to maintenance is, the art of protecting that progress that you've made.
And that's a great phrase to reinforce for people. Maintenance is the art of protecting progress. I'm gonna have to write that one down. I think it's also, back to our maintaining the physical infrastructure. It's one of those things that is really costly and persists over time and has an infrastructure associated with it in terms of people and effort and funding that makes it difficult to get over the momentum that it would take to put that in place.
And quite frankly, it's just not sexy. It's
Yeah.
it's just really not a sexy thing. It's like the plumber when you're building a house. They're not coming in and decorating and painting and helping you stain the floors, but they're very, very, very required. Just no one likes to think about that.
And probably even at the executive level, at the investment level in the C-suite, getting that first model out there and saying, hey, we're recognizing customers when they come in the door so we can provide them better service, and versus the executive that says, okay, I want to spend 10 times that much just to make sure this just continues to do the same job it's doing over time. Nobody wants to make that second business case.
No.
They want to have the flashy first business case and then move on to the next thing. That's potentially problematic.
Yeah, there's no good PR. Yeah, there's no good PR in maintaining something.
Right. Unfortunately, and I think us as smart people, we need to reinforce that and ensure that if you really want to make a difference in your business long term, these are the kinds of things that smart executives that do think in the long term are going to need to think about. And and some do, and don't want to downplay that by any means.
Absolutely.
It's just also though difficult, and when you look at that overall ROI model, it's difficult. Okay, let's get a little bit further into the future. We'll talk about a couple things. One is we mentioned earlier, DALL-E, GPT-3, development of code. The idea of we do have a few flashy instances of AI going to a new level, I think, right now and in the last year in some really interesting ways, where it's gone beyond the recognition, the cognitive services, the baseline prediction, and it's getting a little bit into creating new things. I've got a colleague that we'll do a session on showing off a lot of this creation and metahumans and things like that we can do with AI models. But what's your perspective on where this is headed? AI creating new things at our direction, But where is that at for you now, and what are you excited about as far as that goes?
I see that still actually as going back to the metaphor, somebody's building a better oven or a new type of oven, right? That it is still in research phase. I haven't seen great applications of it out in the wild. I've seen applications of it, but I haven't seen it out in the wild. I think it is a really interesting area. I'm not an expert in that area, but I see it as something that is going to influence things. To be as vague as possible, it influences things, but it is coming, and I think there is a huge onus put on the developers, the organizations, the humanity to ensure that the things that it's creating are not reinforcing the worst parts of us. Simply put, I think we've seen that before with some of the Twitter bots that, the internet can be a very strange, weird, wonderful place, but it can also be a really dark place. And whatever models or whatever data goes into training the models, and even the generative ones, is what the models will come to learn, right? And I think we have to be really careful in thinking about that and having super diverse teams to ensure that these types of things are built with minimal bias, as realistic as that can be.
That's a great point. The digital ethics models associated with it, digital ethics models in force across the creation of the model, the curation of the data. It's a very complicated and very difficult problem. It needs to focus on the inputs more than just analyzing the outputs. You can see some data bias there, but in order to correct that, you're going to need to correct the inputs and have a vision for what it means to have an ethical, balanced, fair model as it's created.
Especially
as far as the application,
especially as it's creating, right? It's not.
yeah.
If it's creating something, it's now putting additional data out there that will then be used to reinforce that bias because it'll become part of the training data too. So we want to filter that out as early and often as possible.
And a form of that creation is decision making, using AI models to help us make decisions about who should get a home loan, that kind of thing. That kind of anything where it's helping us take action or taking action on its own, and creation is one example of that. That is a huge opportunity for us to say, let's put digital ethics in force into this situation to make sure that we're doing it in the right way, both on the inputs and the outputs. Okay. The last area that I wanted to get to is we're sort of thinking even further out about AI and what's coming. Sensational headlines aside, about thinking AI and is AI sentient, or what actual real intelligence might be. We call artificial intelligence, but it's very unintelligent in just putting together a machine learning model that's a neural network. As you think about what it would really take to get to sentient AI, how close do you think we are? How many pieces do you think really need to come together? What are your thoughts there? I have thoughts. I don't think we're very close at all, not to lead the witness, but where do you think we're at, and what does that look like?
I think it really depends on how people are going to be defining sentience and those types of things. Like, I think of sentience as having both forethought as well as reactive emotion to something. Like, it's very human to think about something and then think about doing it, and then having either the happiness if it succeeds or the sadness if it doesn't. Like, to me, that sort of forethought and then ability to react emotionally is the sentient moment. And that is right now very human. It takes in place not just like your neocortex, but like the really, really old parts of the brain, the parts that are like almost reptilian, like the amygdala, the hippocampus, like all of these pieces that regulate emotion. And because I think emotion is such a driver in human behavior, it's hard to imagine how we can program feelings today. I think that there will be groundbreaking stuff. I don't think I know when, I don't think I know how, but it would take a reimagining of machine learning holistically, in my opinion, to really get a sentient AI.
Yes.
Because like you can train something and you can say, oh, it's as smart, they have benchmarks. Oh, it's as smart as an 8th grader. It's as smart as a 7-year-old. But like, smart in what way? It's probably smarter in many ways than that. But does it have that that other piece that is really drives intention and drives desire? Like how do you define desire? And that seems part of sentience too. All these pieces that I think in humanity have very, we almost don't need to define desire because we all know what it is. But at some point it would have to be explicitly stated to a machine who will then develop that. And I think that's where where we are today.
And not only the desire, but the ability to intuit or create, or the spark of creativity for defining new desires and coming up with new things to go after. And then there's the whole self-improvement piece of it, and the growth piece of it that sentience seems to have it as a piece of it. One of the things that we've talked about in the past, which I think we need to take a step back from and isn't as relevant anymore, is things like the Turing test. The Turing test, whereas you could chat with this intelligence in some way, and if it's indistinguishable from a human, then we have to define it as intelligent. I don't think, based on what we know now about how AI works and our machine learning models work, I don't think that's as useful a definition anymore. Or fine, make that a definition, but but set it to the side. All we've created there, and we're getting very good, and maybe we're even there at this point, is creating a model that's very good at just categorizing and understanding what we would expect it to say. And with enough data and with enough data set and a big enough neural network, it will be able to fool us because we've taught it how to fool us. And then you've just created just a machine that is good at fooling people. But you're missing all of those other pieces.
I completely agree that the Turing test is good, especially when creating chatbots or something from scratch. But this goes back to the point of the building the ovens. I can speak for Google. I work here. They've built the oven that can fool us, right? Like we saw that at I/O a couple years ago, where it made the phone call to make the reservation. That 100% is passably human, but not possibly human. I think that's the difference, is that when you have such directed guidance, and then there's this whole concept of the generalization of AI, is it just a combination of a bunch of models that get layered on top of each other? Well, that's not really what intelligence is. Intelligence is the ability to connect across things that don't seem related. And if a machine doesn't do that implicitly, how much generalized intelligence does it have, even if you've stuffed a bunch of knowledgeable machine learning models into it? And I think that's the type of stuff that we might see first before we see a machine be able to be a brain. Right now it's a machine.
Right. It's a very small, specific, well-defined machine that sits in some boundaries. As you're suggesting, AGI will very likely have to incorporate many models, and probably some different types of models that we don't even understand yet today or haven't developed. And then not just here's a whole set of models and it picks the right one at the right time to do a thing. Here's a vision model, here's a speech model, but the orchestration across all of those on top of the idea of creativity and creation and desire and emotion. There's a lot of work. Okay, just to make it really fun, if you had to place a bet on how many years it would take, here's our betting pool. how many years before we get to AGI, artificial general intelligence, something that you and I would agree based on these definitions is artificial and general intelligence? How many years would you say?
Oh gosh, I'm going to look like such a fool when I say like 2 decades, and it turns out it's like literally next year. I don't think it's in the 2020s. I'd be surprised but not floored if it was in the 2030s, and I'd expect something by the 2040s for sure. Unless, of course, like this is the next like AI winter, where it's like we actually have to stop pursuing artificial general intelligence because like we haven't cracked that nut yet, and we haven't figured out how to get there. That it's not that like all AI will become obsolete. I think that practical applications and like cognitive services will be available, but to like there might be less of a pursuit towards that for a while until we have some other innovation and actually understanding like a sort of innovation within the neurobiology space to actually understand a brain, because we can't really build a machine learning model that is sentient like a human, which relies entirely on the brain, until we actually understand the brain, which we have, which we don't.
Right. I think that's a really good point. And that's a great place to look for that AI winter in that particular discipline. So, and I like your prediction of 20 years. I'll say 21 years.
No, is this the Price is Right rules? Like,
No, I agree. I think we're decades away. That would be my prediction at this point as well. So yes, we can think about it. We can speculate. There's more happens in 10 years than you can expect. This was a Bill Gates quote from the 80s or 90s. Fewer things get done in the next 2 years than you think you can get done, but more changes happen in the next 10 years than you expect will happen as well. I still think decades away, even with that in mind. What I hope is not too far off in the future is an opportunity for us to talk again, because this has been amazing. You are brilliant, and it is really fun to talk to people that understand the breadth of these kinds of emerging tech topics. So let's keep in touch, and we'll watch AGI, but we'll also watch all of these more practical things and see as they develop. And as we start seeing models run on the edge, maybe we can catch up and talk about some new examples and some case studies and things like that before too long.
Absolutely. Absolutely. Thank you so much for having me. This has been fun.
Yeah. Thanks so much. And we'll talk soon.
This has been a Nexavise production. For video, links, and to support the show, please visit nexavise.com. That's NEXAVISE.com.